Right now, somewhere in your organization, an AI model is making a decision based on metadata that is technically accurate and operationally wrong. The data catalog says the column is documented, fresh, governed. What the catalog does not say is that the calculation methodology changed last quarter and nobody told the model. The model is confident. The model is wrong. And your team is about to spend 3 weeks debugging an AI failure that was never a model problem. It was a context problem. The question everyone is now asking, should data teams or AI teams own the context layer, is the wrong question. And the way most organizations are answering it is making the problem worse. We've watched this play out across dozens of data organizations over the past 2 years. The teams that avoid silent AI failures are never the ones that won the internal debate about who owns context. They're the ones that stopped treating context as a team deliverable and started treating it as shared infrastructure, with a different operating model than anything most organizations have built. The dominant view is clear and reasonable. The context layer belongs to the data team. The metadata, the business glossaries, the lineage maps, the quality rules, the compliance tags, all of it. Data teams build it, data teams understand it, data teams are accountable for it when the auditor calls. This view has strong foundations. Data teams carry the institutional memory. They know which tables are deprecated, which metrics carry caveats, which upstream sources have reliability problems on the third business day of each month. They have spent years, sometimes a decade or more, curating catalogs and defining governance frameworks. Regulatory requirements under GDPR, HIPAA, and SOX place explicit accountability on data stewards and governance councils, not on machine learning engineers. The context layer is, historically, a data team artifact. Now, there's a second view gaining ground. AI teams should own the context layer because they are its most demanding consumer. AI engineers argue that they need context structured differently, not just what does this column mean, but how does this data behave under different business conditions, and what are the rules for how it can be used in a model. Their claim, if data teams own the context but don't understand how AI consumes it, the context layer will always be slightly wrong for the use case that matters most. Both sides make credible arguments. Both sides are solving a real problem, and neither side's answer works. The first failure mode is the translation tax. When data teams own context exclusively, AI teams must continuously translate catalog-style metadata into operational context they actually need. A catalog documents that the customer lifetime value metric is calculated on a rolling 12-month basis. An AI team building a churn model needs to know, does this metric lag by 30 days? Was the calculation methodology changed in Q3? Are there separate customer segments where this metric is systematically unreliable because the underlying behavioral data is sparse? That operational context does not live in a catalog. It lives in Slack threads, in a senior data engineer's memory, in meeting notes from a business review that the AI team was not invited to. Every AI project pays this translation tax. The cost compounds with each new use case, and the translated context, because it lives in informal channels, is fragile, undocumented, and person dependent. It is a shadow context layer, and it grows in the dark. The second failure mode runs in the opposite direction. When AI teams try to own context, they discover they lack organizational authority to maintain it. They do not control data pipelines, so they cannot enforce documentation at the point of data creation. They do not attend the business review meetings where metric definitions change. They do not have relationships with compliance teams who update regulatory constraints. AI teams that own context become accountable for its quality while having no authority over its inputs. This is responsibility without control. The third failure mode is what happens when the ownership question goes unresolved. Organizations end up with two parallel context systems. The data team maintains the catalog, lineage, definitions, quality rules, compliance metadata. The AI team maintains feature store documentation, model cards, training data, provenance records, and drift thresholds. These two systems describe the same underlying data in different vocabularies at different update cadences using different tools. When they contradict each other, and they will, there is no arbiter. A business stakeholder asking, "Can I trust this AI recommendation?" gets a different answer depending on which context system they consult. This is not inefficiency, it is an active trust destroyer. The fourth failure mode is about speed. Data teams maintain context on a human editorial cadence. Quarterly glossary reviews, annual certification cycles, ad hoc updates when someone files a ticket. AI systems consume context at machine speed. A RAG application needs real-time resolution of ambiguity. A model monitoring system needs immediate context about whether an upstream schema change is intentional or a pipeline failure. A context layer designed for humans browsing a catalog at their own pace becomes a bottleneck, or even worse, irrelevant when AI is the primary consumer. The context layer is not a team deliverable, it is organizational infrastructure. And the question of who should own it contains a structural error, the assumption that one team produces context and another consumes it. In practice, context is multi-authored. Data engineers know lineage and pipeline reliability. AI engineers know feature behavior, model assumptions, and production inference patterns. Business analysts know metric definitions and use case constraints. Compliance teams know regulatory boundaries. No single team holds all the context an organization needs, and no single team ever will. The reframe? Data teams govern the context layer. AI teams co-author it. The platform serves both as a system of record for humans and as a runtime dependency for machines. This is not everyone owns it, which is code for nobody owns it. It is a specific operating model with specific roles. Data governance defines the standards, the taxonomies, the quality thresholds, and the compliance constraints. AI teams contribute context that only they possess, feature semantics, model lineage. Business users contribute domain-specific meaning. Each contributor writes to one shared layer, governed by one set of standards, accessible to every consumer, human or machine. The trade-off is real. This operating model is harder to build than a single-owner model. It requires a platform that supports role-based contribution, not just role-based access. It requires governance processes that can accommodate different contributor types without collapsing into chaos. It requires the data team to accept that their catalog is no longer just their catalog. That is a cultural shift, not a technical one, and it's one of the hardest parts of this transition. But the alternative, the translation tax, the two catalog problem, the accountability without authority trap, it's not sustainable. And it's getting less sustainable with every new AI use case an organization ships. 3 observable patterns support this reframe. First, the proliferation of feature stores as parallel metadata systems. Feast, Tecton, these emerged because AI teams needed context that traditional data catalogs did not provide. Feature stores are not just data serving layers, they are context infrastructure. They document feature semantics, track feature freshness, and record feature lineage from raw data through transformation to model input. The fact that AI teams built an entire separate metadata system at significant engineering cost is evidence that the existing context layer was not serving them. The feature store is the shadow context layer made visible. Second, the emergence of model cards and datasheets for datasets as formal artifacts. In 2019, a research team at Google proposed model cards as a formal artifact. 2 years later, a group of AI researchers proposed datasheets for datasets. Both are attempts to create context that the data catalog was never designed to hold: training data provenance, intended use documentation, performance across demographic subgroups, known limitations. These are not data governance artifacts, they are AI governance artifacts. And right now, they live outside the data catalog in most organizations. Every organization where model cards and data catalog entries describe the same dataset in different systems has a context fragmentation problem. Third, the rise of RAG. AI applications that pull from your organization's own data to answer questions. which makes the context as runtime dependency argument concrete and immediate. Every RAG system depends on metadata to retrieve the right information. Business glossaries to resolve ambiguity, access policies to enforce permissions, freshness indicators to avoid serving stale data. When an LLM-powered application queries enterprise data, the context layer is not a nice-to-have documentation system. It is a runtime control plane. If the context layer cannot be queried programmatically at machine speed with the granularity that AI systems require, then AI systems either operate without context, which is dangerous, or the AI team builds a parallel context layer, which brings us back to the fragmentation. One way this shared infrastructure model becomes operational is through platforms that support both human curation and machine consumption from a single metadata layer. Atlan's active metadata architecture allows context to be contributed by different roles. Data stewards adding governance context, AI engineers adding model and feature context within a single platform, with personas controlling what each contributor can write and what each consumer can see. Atlan exposes this context via APIs and the metadata lakehouse, enabling AI systems to consume context programmatically at runtime, not just through a catalog UI. Atlan's event-driven metadata capabilities through webhooks allow context updates to propagate at machine speed. When quality thresholds are breached, downstream AI systems can be notified automatically, bridging the cadence gap between human editorial workflows and machine speed consumption. This is not the only way to build shared context infrastructure, but it is evidence that the operating model described in this reframe is technically achievable. The blocker is organizational design, not technology. If teams adopt this operating model, three things change. First, the AI team's relationship to the data catalog changes from consumer to co-author. Feature semantics, model assumptions, and drift thresholds enter the same system where lineage, glossary terms, and compliance tags already live. The shadow context layer, the one living in Slack threads and ad hoc documentation, gets absorbed into the system of record. This doesn't happen by mandate. It happens because the AI team finally has a place to contribute context that serves their needs and is visible to the rest of the organization. Second, AI failures become traceable. When the model that uses your customer lifetime value metric degrades after methodology change, the question is no longer, why did nobody tell the model? The question is, did the methodology change get documented in the context layer, and did the model's monitoring pipeline consume that update? That question has a verifiable answer. The failure becomes a process gap, diagnosable, fixable, instead of a mystery that takes weeks to unwind. Third, governance scales to cover AI. Right now, most organizations have data governance and AI governance as separate programs with separate tools, separate teams, and separate reporting lines. A shared context layer does not merge these programs. They have different mandates, but it gives them a common foundation. The compliance team's regulatory tags and the AI team's fairness constraints live in the same system, governed by the same standards, accessible through the same interfaces. That shared foundation is what makes AI governance auditable rather than aspirational. The diagnostic question to ask this week: are AI teams consuming context from the data catalog, or have they built a shadow context system? Check the feature store documentation, check the model cards, check the Confluence pages and Notion docs where AI engineers record what they know about the data they use. If that context does not live in the data catalog, there is a context fragmentation problem, and it will compound with every new AI use case. The first decision to make: stop treating the ownership question as binary. Instead, define the contribution model. Who contributes what context to what system, governed by what standards? Data stewards contribute governance context, lineage, quality rules, compliance tags, business definitions. AI engineers contribute operational context, feature semantics, model assumptions, drift thresholds. Business users contribute domain context, metric definitions, use case constraints, known caveats. One system, multiple contributors, clear governance over who can write what. Now, the longer path: 6 months from now, A team that has adopted this operating model has a single context layer that is both the data governance system of record and the runtime context source for AI systems. Model cards are not separate documents, they are views into the shared context layer. Feature store metadata is not a parallel system, it's a contributor to the shared layer. When a metric's definition changes, both the BI dashboard and the AI model see the change because they consume context from the same source. That is the state most organizations need to reach. The first step is acknowledging that the ownership debate is a symptom of a missing architectural decision and making that decision. The context layer is not a team's deliverable. It is organizational infrastructure, and the operating model matters more than the org chart line. But here's the question this raises. If context is a runtime dependency for AI, who's responsible when it fails? That's a question most data teams have not yet asked, and it's where this goes next.